Good morning all. Welcome back to our video tutorial module 5 part 3. Okay. Today we'll start with the next kind of example on the game. So in the last class we have seen the games that contain a saddle point. In the first tutorial we saw the example on this. Then, in the second tutorial, we have seen the game without saddle point. That is, the game does not contain saddle point. If the game is of 2 by 2, then we apply the arithmetic method, we got the solution. But if the game not contain saddle point as well as it is not 2 by 2, then we go for the next method. The method name is dominance method. As a note, sometimes even the game contains saddle point. In the exam, you may get the question that solve the game by using dominance method. Then no need to check for the saddle point. Directly apply the dominance method steps, get the solution. Just for the verification purpose, at the end, once you get the answer, get the saddle point and value of the game and matches with your answer. Both should be same. Then we will see how to solve the games using the dominance method. In the first step, we have to find each of the rows of the given matrix to be compared with individual rows. For example, if I consider the row 1, elements of the row 1 is less than all the elements of row 2, then we have to delete the row 1. We can say the row 1 dominates row 2 if it satisfies the condition all the elements of row 1 are less than all the elements of row 2. Then we can delete that row 1. Similarly, we apply the second step. For example, if you have taken column 1 with column 2, if all the elements of column 1 are greater than all the elements of the column 2, then only we can delete the column 1. Then we apply the step 3 only when we can't reduce the game to either 2 by 2 or 1 by 1 using above two steps. Then we only go for the step 3, that is the rule 3. In that case, we have to take the average of the next two rows and compare with the first row. For example, if I am comparing all the elements of row 1, then I have to take the average of row 2 and row 3. That is why R1 less than R2 plus R3 divided by 2. If it is satisfied, then only I can able to delete the row 1. Similarly, we apply the same concept for the column also. If C1 greater than C2 plus C3 divided by 2, that is all the elements of C1 greater than the average of C2 plus C3 elements divided by C2 plus C3 divided by 2, then only I can able to delete the C1 column. Okay, so these are the steps we follow in the dominance method to reduce the given game, which is m cross n, to either 2 by 2 or 1 by 1. Once we get the problem is of 2 by 2, then apply arithmetic method, then get the value of the game. If it is possible to solve till 1 by 1, then no need to apply the arithmetic method, directly we get the final answer. Okay. Then we will see the first example. Here the game he has given is of 3 by 3, and it did not contain a saddle point. Then we apply the first step. Compare the row 1 element with row 2. R1 less than equal to R2. So here 5 less than 10 true, but 20 less than 6 condition fails. So this condition not satisfied. Similar check for another operation. R1 less than equal to R3. Here also 20 less than 15 not satisfied. So we have to leave this. Then go for next row operation. R2 less than R3. So all the elements of R2 less than equal to all the elements of R3. So it is satisfied. So we have to delete the R2 row. Once we delete the R2 row, the matrix reduced into 2 by 3. Okay. Then go for the next step, that is column reduction. Then compare column 1 greater than equal to column 2. 520 greater than equal to 2015. No. Then go for next column operation. C1 greater than C3. Elements of C1 are 520. Are they greater than elements of C3 minus 10 and 18? Yes. Then you can delete the column C1. Then after deleting this, whatever the matrix we are obtaining, it is of 2 by 2. Then apply the arithmetic method to get the solution. At same time, we again apply the step 1 and step 2. Check that is it possible to still we can reduce the game to 1 by 1. By step 1 it is not possible. In both the case it fails. Similarly in the step 2 it is not possible. So that we must apply the arithmetic method, get the solution. So after solving this, we got the probability. Then initially optimum strategy for player A, it contains 3 rows, but after doing the operation we have removed that row 2. For that sake we are writing 0 here. Then R1 and R3 column values are as we obtained here 3 by 33 or 30 by 33, or you can write 1 by 11 or 10 by 11. Okay. Similarly, for the player B, initially we are having 3 column, but after deleting this, we get only 2 column values. So, first column we deleted 0, remaining are 28 by 33, 5 by 33. Then value of the game is 510 by 33. It is positive, and it is advantageous to player A. Similarly, we solve second problem. Here 2 minus 2 4 1 first row, second row 6 1 12 3, third row minus 3 2 9 6, 2 minus 3 7 1. So we apply the same row reduction and column reduction. First row deleted, second row 4 is deleted. Similarly step 2 column 3 is deleted, column 4 deleted. Then again check that can we further reduce the game by applying step 1 or step 2? If possible, reduce it. Else, go for the arithmetic method, solve the game. Okay. Here also we deleted the row 1 and row 4, deleted column 3 and column 4. So only we write the remaining answers here. Then we get value of the game is 3 by 2. It is advantageous to player A. Then another kind of problem, it is third problem. Here we apply the row reduction, column reduction. Initially we deleted the R1, then we deleted the R4. Similarly we delete second step C2, C4, C5. 3 columns are deleted. Then at the end we got 2 by 2 matrix. Then check that is it further reducible or not. Yes. By applying first step, it is further reducible. So we can delete R2. When R2 is deleted, only R3 is left. Then for this, can we apply step 2? Again check it out to satisfy. So that delete C3, only one value is left. So this is the value of the game. Then no need to apply the arithmetic method. Hence, optimum strategy for player A is only one row value we obtain. It contains a saddle point, so that R3 is the value, row 3, and column 1 is the strategy for player B. Then next problem, here we need to reduce this problem to either 2 by 2 or 1 by 1. So applying step 1, we can delete the R1. Okay, we have deleted only one row, but further reduction is not possible from the first step. So we go for the step 2. In the step 2, we can reduce the matrix by deleting the column 1 only. Further reduction is not possible. Then when step 1 and step 2 does not make the game into 2 by 2 or 1 by 1, then we go for taking the average. Here it is an important note is that always take column average first. Even though in the problem initially we have taken a row average, but while solving the example we must take the column average first. Then here we apply the C2 greater than C3 plus C4 divided by 2. So these two conditions satisfied. So we are going to delete that C2 column. Then similarly do for R2 less than R3 plus R4 divided by 2. So we got satisfied. So we delete the R2 row. So only R3, R4 left, C3, C4 left. Then for this we can apply the arithmetic method. We can't reduce it to further one by one. So apply arithmetic method, get the solution. We got the value of the game is 16 by 3. So it is advantageous to player A. Next, we will solve in the next tutorial. We are going to solve the last method in the game 3, that is graphical method. Okay, thank you.